This call is now being recorded.
Good evening, everyone. Again, today is the class 8th of the Aksharamaala initiative. I'll be continuing from where I left in the last class. In last class, whatever I covered, I'll quickly recap the things. Recap of class 7, and after that, we will continue with the numericals for what we studied in last class. So, we did some numericals on Ohm's law and the resistance of a conductor made out of material of resistivity rho and given physical parameters. So we verified also through the numericals that for smaller length, and given that A and rho are same for the two conductors, for smaller length the resistance is less. And if length material are same, and if cross section area is small, then resistance came out to be large out of the two. And the other one was direct relation of resistivity itself. Greater the resistivity, greater the resistance for the same physical parameters. That was it. And then we studied the combination of resistors. There were two ways so far in which we could connect the resistors, and that was series combination and parallel combination. In series combination, the features were that the voltage was divided. This voltage is divided. Current is same. This one is across the resistors and this one is through the resistors. So V, it breaks into its components, and I remains same throughout the resistors because there's only one arm, that is in all the resistors are connected in series. Say R1, R2, R3 up to maybe Rn, as long as we want it to be. So using Ohm's law, if we take the net resistance of the circuit to be Rs, then individual drops will be given by this IR1 across R1, that is V1, V2 equals to IR2, and so on. I can be taken to be common plus R2. So if we cancel out, so this was the result which we got. The net resistance of the series combination is simply the summation of all the series resistances. Then the other was parallel combination. In parallel combination, voltage was same, or you can say the potential difference was same across all the resistances, and current was divided. Current was divided through the nodes at these points where the arm would diverge into several resistances, number of n number. So the current would divide among the resistors. So current was divided, voltage was constant. We can again apply Ohm's law here. that is V equals to IR. This gives that I equals to V by R. So each current which was following through the RI resistor, potential difference across the resistor was V for each of them. II, that is ith current through ith element or the ith resistive component, is given by V by Ri. So this equation, this one, this becomes V by R parallel, that is the total resistance of the circuit, will be given by V by R1 plus V by R2, that these individual currents, these can be written using this formula, plus V by R3 and so on up to the n number of components. So from here, V is common and will be cancelled out among all the terms. We get net resistance of parallel combination to be simple sum of the the reciprocal of the net resistance is equal to sum of the reciprocal of individual resistances. What does that mean is, you simply take the inverse. Suppose this is the circuit. This is A, this is B. This is R1, R2, R3. So how will we calculate the parallel resistance is the sum of the reciprocals of individual resistance, that is reciprocal of R1 plus reciprocal of R2 plus reciprocal of R3. This would be the reciprocal of net resistance, which is RP. So once we sum all these three terms, we again say it comes out to be X. So to find the net resistance, we have to again take reciprocal on both sides. So that it gives us RP. That is the net resistance of the parallel combination of resistances. Or we can simply say of the parallel combination circuit. This was all which we did in last class in the numericals. Let's continue with the numericals this time. So there's the question. I think this one we have done last time. I did not mark it. This one. All right. So I hope you can see it. Question is that it is a NCRT example. An electric lamp whose resistance is 20 ohms and a conductor of 4 ohm resistance are connected to a 6 volt battery in figure 12.9. This one is the figure 12.9. Calculate A part is the total resistance of the circuit, B the current through the circuit, and C is that the potential difference across the electric lamp and conductor. This is a simple question. We are given with the 6 volt battery there is a 4 ohm resistor, and this is an electric lamp here which has a 20 ohm resistance, sorry. So we are asked to calculate the total resistance in the A part, which is simple. We see at these points we can change the or replace the total resistance with the series resistance, because the resistors are connected in series, that is end to end, only on one end, and the other two ends, these are for the circuit. So Rs becomes R1 plus R2, which is 4 plus 20, and it comes out to be 24 ohm. This is the first part. B part is the current through the circuit. So once we have calculated the total resistance, now we can use Ohm's law, that is V equals to IR, to find the current. V by Rs, I equals to, and given that battery voltage, it is 6 volt, 6 by 24, 6 1 the 6 4 the 1 by 4 is 0.25, and units are ampere. This is one answer. This is another answer. Now the C part, they have asked to calculate the potential difference across the electric lamp and conductor. In this C part, the task is to calculate potential across conductor. Let's say it's V1, and potential across the lamp. Let's say it is V2. So in series combination, we saw in the last class and in the recap also that voltage divides and current remains the same. So using Ohm's law, we can easily calculate V1 as IR1 and V2 as IR2. So I we calculated is 0.25 ampere and conductor resistance is 4, so it becomes 1 volt potential drop across the conductor, and V2 will be similarly 0.25 into the resistance is 20 ohm, so this becomes 5 volt. And you can from here confirm also that sum of all the potential drops, 1 plus 5 is equal to 6, is equal to the battery voltage, that is the source voltage we have applied, which was divided among the components. So that solves our question. Is there any diagram required? No, question is enough. So these are the new questions. Now first question is, draw a schematic diagram of a circuit consisting of a battery of 3 cells. Like, solution 1, battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor, and a plug key, all connected in series. So we have to draw a schematic diagram for series combination. Components that are given to us are a battery, of voltage They haven't given voltage directly. A battery that is comprised of three cells. So its symbol will be like this: 1, 2, and 3 cells combined in series. Each of the cell voltage is 2 volt. It's given in the question. So the battery voltage will be 3 cells, that is 2 plus 2 plus 2, or 2 into 3. So V battery will be 6 volt. And the rest things that are given, is there are the resistors. One is a 5 ohm resistor, another one 8 ohm, and another one is 12 ohm. And there is another component which is given is plug key, which we have seen again and again, which is used to close the circuit. This one. The resistor symbol is this, fixed resistor symbol. Plug key symbol is this for the open circuit, and this one is for with the plug inside. It is a closed key, you can say, or closed circuit, and open key. We have to combine all these components. First we put the battery. It is 3 cells. This is 6 volt. And we can put the key next to the battery. Then there are 3 resistors. This is 5 ohm, 8 ohm, and 12 ohm. Close the circuit and current flows through the circuit. So we have to write this also, like figure and tell about this. We cannot just leave the diagram. Schematic diagram for given question or given problem. Just this much would do, but it is necessary to write this. Now the question number 2. Redraw the circuit of question 1, putting in an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and the voltmeter? So now they have asked us to modify this circuit. Just a sec. I'll just draw it again. Never mind. So in question 2, we have to redraw the circuit quickly. 6 volt battery, plug key, 3 resistors. I will stop here. 5 ohm, 8 ohm, 12 ohm. They've asked us to input an ammeter, and a voltmeter across the 12 ohm resistor. So they have asked us to calculate this current, and this potential, this is V3. So what are the values for this? So first we will have to calculate the total resistance, that is the series combination resistance, and will basically be the sum of all the three resistances, which is 5 plus 8 plus 12. So net series resistance comes out to be 25 ohm. Now using Ohm's law, current can be calculated easily, which is I equals to V by R, or here I is equal to V by R S. So I comes out to be 6 volt battery source, and 25 is the net resistance. Let me get the calculator. So the current comes out to be 0.24 ampere. 5 is 5 1.2, 5 1 is 5 2 is 10, 5 4 is 20. Yeah. So this is the current. Now they have asked us to calculate the potential across the 12 ohm resistor. Since this is series combination, I is fixed, V is divided among the components. So V3 is, say the third resistor is the 12 ohm resistor. V3 is the potential across the R is equal to 12 ohm. So V3 becomes I times R3. So V3 is simply 0.24 into R3, that is 12 ohm. So this becomes 2.88 volt. This answer coordinate instrument. Okay, 12.10, okay. Example 12.8. In the circuit diagram given in figure 12.10, suppose the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a 12 volt, to a battery of 12 volt. So they have asked us to calculate the current through each resistor, the total current in the circuit, and the total circuit resistance. So this is clearly a parallel combination because resistances have been connected end to end on both sides. And this R1, R2, R3 values are given as 5, 10, 30 respectively. Respectively means that if I write R1, R2, R3 like this and 5, 10, 30 like this, so respectively means first value with first value and second with second, third with third, and so on. So R1 is given is R1 is 5 ohm, R2 is 10 ohm, and R3 is 30 ohm. So battery voltage is 12 volt. This one. Calculate the current through each resistor. Since it's a parallel combination, V will be fixed and current will be divided. So current through each resistor from ith jth component will be V by resistance of jth component. So I1 becomes, using Ohm's law, V by R1, that is equal to 12 by 5. I1 then it comes out to be 2.4 ampere. Excuse me. Similarly, I2 is V by R2, comes 12 by R2 value is 10 ohm. Simple. 1.2 ampere. I3 is equal to V by R3 again. It is 12 by 30. Becomes 1.2 by 3. So it becomes 0.4 ampere. They have asked to calculate the total current in the circuit and the total circuit resistance. So simply, if you see here, MQT and Y, we have this node. I'll explain it there only. It will be better. Say this is I1. Say this is I2. This is I3. And this is total current. So I1 plus I2, I3 comes out to be I. So total current through the circuit will be I1 is 2.4 ampere plus 1.2 plus 0.4. So current comes out to be 2 plus 1, 3, 4 ampere. They have asked us to calculate the total resistance. There are two ways. One is the direct way that you calculate the resistance using the formula, which is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So with this you can get 1 by 5 plus 1 by 10 plus 1 by 30. Now Rp becomes 30 is the LCM. It becomes 10 by 30 or 1 by 3. This implies that Rp is equal to inverse, it is 3 ohm. Alright. The other way around is we just calculated the total current through the circuit. So we can use an alternate way, which we are now quite familiar with, that is Ohm's law. The battery voltage is 12 volt. The current we found is 4 ampere, and this is the total net resistance, which is Rp, or you can write R net also. So R net will become 12 by 4, that is 3 ohms. Which one is much straightforward once we calculate the total current through the circuit. This one also. In figure 12.12, okay. So this and this. For some reason I can't paste both of them. Let's try. Oh, it works. Nice. Question example 12.9. If in figure 12.12, this figure is 12.12, R1 is 10 ohm, R2 40, R3 30, R4 20, and R5 60. These resistance values are given to us, and a 12-volt battery is connected to the arrangement. This source is 12 volt. Calculate the total resistance and the total current flowing through the circuit. So let's get started. First, let me rearrange this circuit a little bit. First, we have a battery of 12 volt. Then there is this combination of resistances R1 and R2. R1 is given to us 10 ohm, R2 is given 40 ohm. Then there is ammeter. We can place the ammeter near the battery also, so we don't have to put it there only. We can shift the components to make it easy to understand. Then there is another parallel combination of three resistances this time, something like this. And R3 is 30, R4 is 20, and R5 is 60. We have to calculate total resistance. So we can calculate the resistance between these two terminals. Say it is X and Y. It is easy. This one is the first parallel combination. This is second. So let's calculate them step by step. For the first one, it is a parallel combination of two resistances, 10 ohm and 40 ohm. So R parallel, 1 by R parallel comes out to be 1 by 10 plus 1 by 40. So 1 by R parallel is equal to 40 LCM. 4 plus 1 is equal to 5 by 40. 5 and the 5 at the. So RP becomes 8 ohm. Let's say RP1 because there are two parallel components. Similarly, for second one, there are three resistances this time. Thirty, 20, and 60. So 1 by RP2 becomes 1 by 30 plus 1 by 20 plus 1 by 60. 1 by RP2 becomes 60, that is 2 plus 3 plus 1. 1 by RP2 becomes 2 plus 3, 5 plus 1, 6 by 60. And the 6 times are, this implies that RP2 is equal to 10 ohm. So the net resistance is basically that if we put a single resistance in place of this whole circuit, then the current through the circuit won't change and the potential drop across this complete system and this one resistor will be same. So it acts as a replacement for it. So now we can replace these two individual parallel combinations with single resistances with RP1 and RP2. So our circuit will now something look like RP1, RP2. Then there is a 12 volt battery. Let me check if it's 12 volt. Yes, it is. And for the moment, we can just leave the key and ammeter because we are interested in resistances and current. For now, resistance. So this one now, between X and Y, we have two resistances and they are now in series combination. Individually, they were in parallel, but these two parallel circuits were in series with each other. So Now the total resistance will become Rp1 plus Rp2. So Rs becomes Rp1 is 8 ohm, Rp2 is 10 ohm. Comes out to be 18 ohm. This is the total resistance. So first part is the total current flowing in the circuit. Which becomes easy after calculating total resistance. Simply we apply Ohm's law, which says V equals to IR. So I is V by R. This implies I total is 12 volt by the net resistance, that is 18. 6 2s are 6 3s are. So current becomes 2 by 3, that is approximately 0.67 ampere. This is our answer. B part is also done. It has again started to lag. Just bear with me. This is the new set of questions. And let me remind you again, these all are NCRT questions. So if you pay attention to it, then it will be beneficial for you only. They might ask these questions in exams also. Question 1 is, judge the equivalent resistance when the following are connected in parallel. Solution on A part, 1 ohm and 10 to power 6 ohm. So they haven't asked us to calculate, but to judge. So how would we judge is that, let me show you quickly. Parallel combination is like this. So if one resistance is very big as compared to the other resistance, then what happens is that, let's say in this value, 1 by 1 and 1 by 10 to power 6. So this is 1 ohm resistor. This value simply is 1. But here we see that there is a large value upon 1. So reciprocal of large value is very small, and larger the value, smaller the 1 by large value. So this value is less than 1. Similar, like suppose there is 1 by 10, it comes to be 0.1, which is comparable to 1 in, although it's not very large, but still, if I add to 1, then there is a noticeable change. It becomes 1.1. But if I divide by 100, then it becomes 0.01. So 1 plus 0.01 will be 1.01, which is again approximately 1 only. And if I keep on increasing this denominator number for 6 zeros, it will become 0.0000001. 5 zeros, then 1. So 1 plus this thing becomes 1.0000001, which is more or less same as 1. So the large resistance gets neglected if the other resistance is very small as compared to the large resistance. So this goes to 0, or we can simply say that 1 plus this small value, this much, will be again as 1. So simple key here is that if the one of the resistance is much greater than R1, then the net resistance, it will approximately be equal to the smaller resistance. as this R2 this approaches to infinity, that is a very large value such that 1 by R2, 1 by infinity becomes 0. So total resistance will become equal to R1, that is a smaller resistance. So in first part, A part, we judge that out of 1 ohm for parallel combination 1 ohm of 1 ohm and 10 to power 6 ohm, our net becomes to be 1 ohm. B is 1 ohm, 10 to power 3 ohm and 10 to power 6 ohm. Again, same thing. If there is one small resistance and other are very large, no matter how many resistances, then the total resistance will again be approximately 1 ohm only. But if all the resistances are large, say 10 to power 6, and the second one is also 10 to power 6, then there is no neglection because both are comparable. So it becomes something like this. That is half the value of the one of the resistances. So it becomes 0.5 into 10 to power 6, which is still quite big, not a small number. 10 to power 5, sorry. Second question is, an electric lamp of 100 ohm, a toaster of 50 ohm, and a water filter of resistance 500 ohm are connected in parallel to 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all three appliances? And what is the current through it? Okay, so first we are given three components in parallel and connected with a 220 volt source. Assume it to be DC because AC has not been mentioned. The resistance of three components is 100 ohm, 50 ohm, and 500 ohm. So they have asked what is the resistance of an electric iron connected to the same source. Suppose there is another case where only one iron is connected. Iron means that appliance which we use to iron our clothes. Not very intuitive though. Let us continue. What is the resistance of this iron connected to same source takes as much as current as all three appliances? Suppose in first circuit the current is I, and in second circuit also they say this iron takes same amount of current. So what will be the resistance? So first you have to calculate I from the first case and put it in the second case and get the R value. So how will we do that? There are two ways. In first case, first calculate the total resistance. Once you get it, I will be V by R total. All right. This is one way. Excuse me. Second way is calculate current through each component. Ij, which will be V by Rj, and then sum over all those components. Second one is easier because Rp is a hazard to calculate. So let's calculate it by second way. I1 will be V by R1. I2 will be V by R2. I3 will be V by R3. 220 by the resistances. R1 is the first one, let's say. I1 is this one, I2 is this one, and I3 is this one. So 150 and 500. This becomes 2.2 ampere. This is double, so 4.4 ampere. This one becomes 0.44. No. Yeah, 0.44 ampere. So total current becomes total current through the circuit I is equal to summation of all the currents. So I becomes 2.2 plus 4.4 plus 0.44. This becomes 6.6 plus 0.44, that is 7.04 ampere. So now they asked us to calculate the resistance of iron, which will draw the same amount of current from the same source. So apply Ohm's law. Current is resistance is V by I. This implies the resistance of iron is equal to 220 by 7.04, which comes out to be 31.25 ohm. This is basically the parallel resistance of the parallel combination. If you calculate the resistance, then you have to calculate the current simply by V by Rp, which is the first method. And this is the second method. First you calculate the current, then you tell the resistance. Same problem, two ways to do it. First is done, second is done. What are the advantages of, next question, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? So we have to write the advantages. If the components are connected in parallel, suppose there is in the house, there is a fitting of bulb and there is say electric fan, just for the sake of example, and the bulb fuses out, or you can say that it gets burnt due to some irregular fluctuation in the power supply or due to its life, or say some fault in the production. This one dies out. So this path is now broken and current will not go through it. The current comes here and instead of stopping, it will start going through only electric fan. So the fan will not stop working. Whereas in series, if bulb dies out, then the current will stop here only and the fan will also not work. So the first and greatest advantage is that if one component dies out or simply say removed, from the circuit. And these components are only the resistive components. If we take out the battery, then nothing will work. Only the resistive components. If one of the resistive components dies out or is removed from the circuit, then the other components will continue to function. What can be other advantage of parallel combination? In parallel combination, we have, if we have put the resistances in parallel, then we can produce low resistances. Suppose we have a 1 ohm resistor and 10 to the power 6 ohm resistor. So we want a resistor even smaller than 1 ohm, or we need to accommodate these resistances such that it offers a low resistance to the flow of charges or the flow of current. So we simply connect them in parallel and make a low resistive path. It's not of that much use. We can, because we can simply use a low resistance value, but still it can be counted. So for now, I know only these ones. Next question. How can three resistors of resistances 2 ohm, 3 ohm, and 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? This is an interesting question, often asked in exams also. I think it was asked in my 10th exam also. So, given is resistances of 2 ohm, 3 ohm, and 6 ohm. We have to find combinations of these three resistances such that the total resistance comes out to be 4 ohm in A case, and other case it comes out to 1 ohm. So we have different ways to connect the resistances, that is two different ways, that is series and parallel. So let's try out how can we make this much resistance. If we connect 6 and 3 in parallel, let's see how much resistance we get. And one more thing, if we have only two resistance in parallel, then there is a short formula also. Take LCM R1, R2, here comes R2 and here comes R1, take reciprocal, RP becomes product of two resistance divided by sum of two resistances. This is a trick formula. So for 6 and 3 it will become 6 into 3 and 0.6 with 18 by 9, that is 2 ohm. So yeah, this will work out. For the first case, we can put the 2 ohm resistor like this, and in series with it we put the 3 ohm and 6 ohm like this. So this will give us 4 ohm because first is 2 ohm. If we solve the parallel, we get 2 ohm. Then it is a series combination. So 2 plus 2 is 4 ohm. So this is the answer. This circuit itself. In B part, we have to create the resistance to be 1 ohm for the same resistor values. So we have 2, 3, and 6. So we cannot connect them in series in any way. Like if we connect them, it comes to be 11. Let me tell you also how I did here. So see, we had to make 4 ohm. So 2 ohm was already there. If we add 2 ohm to it, then we get 4. So I was checking if parallel of these will give 2 ohm, and that worked. Other way around, if we put 3, then parallel of 6 and 2 should be 1. But that would not be the case, because 6 into 2, 6 plus 2, that is 12 by 8. This is not 1, clearly. And we cannot put anything in series with 6 because it already surpasses 4. And if we connect all of them in parallel, then the resistance will be the less than the least one, that is even less than the 2 ohm. So let's see here if we connect all of them in parallel. That formula R1, R2, this works for only 2 resistances at a time. You can apply it here also, but in a slightly different manner. I'll show it to you. 1 by 2 plus 1 by 3 plus 1 by 6, 1 by RP, 6, 3, 2, 1, 3, 2, 1, 6, 6, 6, 1. This implies RP equals to 1. Other way you can do is do for 3 and 6 and let 2 ohm be like this. 3 6 upon 3 plus 6, which we did earlier, 9 by 18, that is 2. Now for 2 and 2 you apply again. So 2 into 2 upon 2 plus 2, it is 4 by 4, cut 1. This is the answer itself. Last question is, what is the highest, the lowest total resistance that can be secured by combination of 4, 8, 12, 24? 4, 8, 12, 24 ohm resistances. What is the highest? Let me check the question again if there is, I have made any mistake. The highest, the lowest. Yeah. So highest resistances can be created by connecting all of them in series, because it adds up the values. So greater the value of the resistance, greater its contribution in series. Just add these. It gives 12, 12, 24, 48. Lowest value is in parallel. The greater the resistance, the minimum will be its contribution in parallel, because there we add the reciprocals. So 4, 8, 12, and you can make other connections and check if you get the resistance value greater than 48 for any of the combination, and the value minimum than this parallel combination, 4, 8, 12, 24. I think it's lagging again. Just 2-3 seconds, it will restart. Yeah, it's lagging. So here the resistance will be 24 plus 1 by 12 plus 1 by 8 plus 1 by 4, 1 by R total, 24, 1, 2, 3, 6, 6, 3, 9, 9 to 11, 12, 1, 12. Sorry, 6, 3, 9, 9 to 11, 11 plus 1, 12. It is 1 by 2. So this implies that RP is 2 ohm. Least value, not the least, but the minimum. let's say lowest value, and 48 is the highest value. So these were some questions, and let's see if there are any other left. And this is from next topics. This is also done for parallel and series combination. You've done all the examples in NCRT. Time is also up. So next time we will continue with Joule's heating law. Applications of it, power, and again we'll do numericals. Thanks for watching. If you have any doubts, you can put it here in the Aksharamaala platform, as I say usually. I hope it does not log me out. So far, 8th classes. Today is 8th class, 8th Jan 2022. It's not working. Fine. Yeah, so that's all for today. Join next time. I'll put assignment also for it. Thank you.